The long-awaited Chanfeng mailbox.
890 mailbox and the old 790 are mailbox.
Then we are now conducting a sampling test.
We sampled half of the mailboxes, and then we call each one a sample and give it a number, and give them a number according to area.
Numbered by area.
Let's take a look at this one from Chanfeng, which is called
It's sample A.
Then this 890 mailbox is B.
Now we are cutting this side of it.
Is the right side. So it's called R.
We code each area with AR1, AR1 bar 2.
R12, then 211, and so on for each part.
And each part has a corresponding number.
We can know the intensity of each part, its strength, and approximately.
Although the two fuel tanks are not exactly the same, but we can still see some key points. It's this here AR3 one, and this one.
And the one below, AR bar 8. AR bar 8. And the ear of 890 is broken. Is already broken.
So we will take this half of it at that time for testing later.
Anyway, the general testing method is like this.
After we finish drawing the pictures.
Then we will cut it open after cutting for each small piece.
And at different temperatures.
And according to national standards.
Try to follow the National Fuel Tank Safety Standards.
To conduct a test. If it can't even pass the national standard.
It means that the fuel tank is definitely unqualified.
Let alone off-road.
Okay.
And then for the remaining half of the fuel tank. Because each fuel tank has two sides.
We try to keep it still, because if you don't agree with the test result, we will take this entire half of the fuel tank.
We will test it according to the national standard.
You said it meets the American standard.
The American standard. And then we will test the entire fuel tank.
And test this half of the fuel tank.
We have cut this fuel tank today. Let's take a look. We cut it according to this number.
We found that during the cutting process. We found a problem. We haven't started testing yet.
It's the problem of the bubble.
This fuel tank.
There are many bubbles after cutting.
How much we cut?
There are many bubbles. And the bubbles on the side wall of the fuel tank.
Do you know the rotational molding? Brothers who are familiar with plastic. Is this process normal? The ear's cut off from the top just now.
Look at this big honeycomb bubble.
It's so big.
This is an obvious structural weakness.
Do you know why it broke?
The break is caused by the unbalanced force at these points.
It breaks at these places first. And this is the 890 fuel tank. There are also bubbles. There are random bubbles.
Or if the bubble appears at a weak point.
Bubbles.
If this kind of bubble appears at a weak point.
Like the ears of the tank.
It is likely to break.
It's 890. Look at this honeycomb. Honeycomb bubbles on the fuel tank wall. The fuel tank was damaged during transportation. This part is cracked. It's not cut, right? Look, it starts to crack from here. It started to break from the bubble. And then look at the middle of the rotational molding. There are bubbles. Cut a little bit. The weak point will break.
So it's a random weak point in the structure.
I don't know where it will break. If this bubble
is at the place of the ear just now,
the weak point would break down immediately.
It hasn't been sent to a professional agency for testing. We can already see so many problems.